Okay, so now welcome back. So in this video we wanted to basically work on exercise 13.2, which is basically not a lot of around 11 exercises on derivatives. Now suppose that you want to, for example, find the derivative of x squared minus 2. You want to find the derivative of x squared minus 2. X squared minus 2 at x is equal to 10. So suppose that this is a function f of x is equal to x squared minus 2. Now this is going to be a function basically a parabola, something like this, but the vertex of the parabola is not at the origin but shifted down 2 units. So it's going to be something like this. And so at x is equal to 10, we're going to be I don't know, probably somewhere over here, and so you would get your output would be way up here, meaning that it's around 100 minus 2 is equal to 98, way up here. And at that point the function is already way too steep. So that means that the tangent line that you could draw to the function at that point, the slope of that line is going to be something like, for example, something like this, meaning that the slope of the line is way too high. So meaning, for example, something about a 50 or even 60 or something close to 100, probably even. So let's see what we get over here. So suppose that you have, now if your function is f of x is equal to x squared minus 2, then to find the derivative of this function, d by dx of f of x is equal to basically d by dx of x squared minus 2, which is basically d by dx of x squared minus d by dx of 2. So d by dx of x squared is equal to 2 times x, and d by dx of a constant is equal to 0, which is equal to 2 times x. And as you can see, the derivative of the function at this point is going to be already around 200, meaning that 2 times 10 is equal to, 20. So then the derivative of this function, meaning that if your function is f of x is equal to x squared minus 2, then f prime of x, which is equal to d by dx of f of x, is equal to 2x, and it is actually equal to the derivative of x squared. If your function was f of x is equal to x squared, your derivative would still be f prime of x would still be basically 2x. So it seems that it doesn't make any difference whether your function is shifted up or down, the derivative remains the same. And the reason for that is that I don't know what the reason is, because when you shift your function up and down, for a given basically input, your output is going to change. And so that means that your output is going to change, and that means that basically the derivative has to change as well, but it doesn't. Anyway, let's not think about that. So now the derivative of f of x is equal to 2x, and so then f prime of 10 is going to be equal to 2 times 10, which is equal to 20. So the derivative of the function at that point, at x is equal to 10, is going to be equal to 20. And what that means is that basically 20 is the slope of the line that touches the graph of the function at x is equal to 10. So that means that f prime of 10, which is equal to 20, is the slope of the line, is the slope of the straight line, that touches the graph of the function, of the graph of basically f of x at x is equal to 10. At x is equal to 10. Now at x is equal to 10, your function is f of x is equal to x squared minus 2. So then f of 10 is equal to basically 10 squared minus 2, which is equal to 100 minus 2, which is equal to 98. So f of 10 is equal to basically 98. So that means that that point is 10 comma 98. Is 10 comma 98. So if the point is 10 comma 98, and if the slope of the line is 20, then y minus y1 is equal to m times x minus x1, and that gives you basically y minus 98 is equal to 20 times x minus 10. So y minus 98 is equal to 20x minus 200. So y is equal to 20x, and negative 200 plus 98 is equal to negative 102. It's negative 102. Now if I draw the graph of the function, here, and then I'll show it to you. So suppose that the graph of the function was x squared minus 2. X squared minus 2. And the equation that we found for the line which represents the derivative is basically f of x is equal to 20x minus 102. Minus 102. So as you can see over here, at this point, so this point is 10. At this point, 9.9, 10.98. If I change the color over here, there's no way to change the color, but you can see f of x is equal to what? 20x minus 102. 20x minus 102. And as you can see, basically the blue line represents somewhere over here. You have 9 and 10 over here. That is the point. So you see that basically the line is touching the graph of the function, well, exactly at that point. You can zoom in and you can see that you see over here. I'm zooming in to see where exactly the line is touching. Seems that somewhere must be around 98. It must be around somewhere over here. What was the point? At 98. Exactly at this point. It's taken all of these points at 10 as 10, 98. Anyway, it doesn't have, I mean, you don't get more precision or accuracy with this graphing calculator, it seems. Okay, so the first part over here, let me find the correct answers here. Let me see if the answer is actually correct, which is basically main ebooks. Go over sheet mathematics class 11 answers and go to 13.2. Go to 13.2. Is 20. The right answer is 20, so that the value of, basically what that means is that the value of the derivative at x is equal to 10 is 20, the right value. Anyway, the next question that we have is we want to find the derivative of x at x is equal to 1. We want to find the derivative of x at x is equal to 1. Okay, so to find what it means to find the derivative of x at x is equal to 1, suppose that you have a function f of x is equal to x. So this is just a straight line with slope 1. This is f of x is equal to x. And on this line, the slope everywhere, m is equal to 1. The slope of this line is everywhere is equal to 1 because it's a straight line. Now, since so that means that basically you can say that the slope of this function, or basically f prime of x, which is equal to basically is equal to 1, and of course you can say that f prime of any x, basically I can call it a, for example, is equal to 1, meaning that the slope of the function at any x is equal to 1. And of course you can say that the f prime of 1 is equal to 1. And the right answer is 1. Of course, to take the derivative of this function, when you have f of x is equal to x, then you know that d by dx of f of x is equal to, we said that when f of x was equal to x raised to the power n, then d by dx of f of x is equal to n times x raised to the power n minus 1. So n times x raised to the power n minus 1. So then over here you have x raised to the power 1. So then d by dx of f of x is 1 times x raised to the power 1 minus 1, which is equal to 1 times x raised to the power 0, which is equal to 1. X raised to the power 0 is equal to 1. So this is 1. And that's basically how you find the derivative of this function. Okay, so question number 3 is find the derivative of 99x at x is equal to 100. You want to find the derivative of 99x. Let's call it, for example, f of x. Let's call it f of x is equal to 99x at x is equal to 100. So basically this is a straight line. This is a straight line whose slope is 99, meaning that the graph of this function is basically just a straight line with a slope. For example, if I call this, for example, 1 unit, and if I call this, for example, 99 units, then the function basically goes through these 2 points. The function goes through these 2 points, and this is f of x is equal to 99x. Now you can see that basically, since this is a straight line, of course the slope of the line is 99 at any point on the graph of this function. So you can just simply say that f prime of x is equal to 99 at any point. F prime of x is equal to 99. And of course I'm saying at any point because there is no x here, meaning that if I set f prime of, for example, 1, it's going to be 99 because there is no x here for x to be important here really. If I calculate f prime of 2, it's going to be 99. If I calculate f prime of 3, it's going to be 99. If I calculate f prime of a, it's going for any a, and in the domain of the function, it's going to be 99. So what that means is that at x is equal to 100, you can say that f prime of 100 is equal to 99, which is basically nothing but the slope of the function at that point. The slope of the function at that point. So the answer over here is, question number 3 is 99. Now question number 4, you want to find the derivative of the following functions from first principle. From first principle. So let's first see what the first principle was, and then so we said that the first principle was basically the first principle of derivative. Okay. So we said that basically f prime of x, based on that configuration, based on based on the construction that we had basically a construction over like this, and we had basically a function over here, something like this, and then we took this, for example, as point A, and we took some other point as, for example, Q. So this was point, for example, P, this was point Q, and this was A plus H, and this distance was therefore H, and then this is basically P of or F of A plus H. F of A plus H. This point over here is F of A. So we said that basically if you basically take if you want to calculate the average velocity of the object, or the slope of this line, which is the average velocity at these 2 points, it's going to be equal to the slope of this line. And then as we moved Q towards P, the slope of this line changed until finally we got to some line whose slope was something like this. The slope was something like this and was touching the graph of the function at this point P. Now, and of course this line basically goes through the x-axis at an angle, and we call that angle psi. We call that angle psi, and of course the slope of this line is tan of psi. So the slope of this line, whatever you want to call it, is basically tan of psi. Tan of psi is equal to the slope of this line over here. And basically we had already found out that the derivative of the function at point A was equal to the limit of f of A plus H minus f of A over H as H tends to 0. And then based on a couple of triangles over here and so on and so forth, we basically got this this relationship, which was f prime of x is equal to the limit of basically f of x plus h minus f of x over h when h tends to 0. When h tends to 0, and we call this the limit of the derivative of the function, the general limit of the general derivative of the function, and this is, by the way, equal to tan of psi, of course, equal to tan of psi. But basically the important part over here was basically this part, and I don't want to go through all of those triangles and so on and so forth. We already have done that. So the function defined by defined by the limit of f of x plus h minus f of x over h as h tends to 0 in the limit, wherever this limit exists, is defined to be the derivative of f at x and is denoted by f prime of x. Now this definition of derivative is also called the first principle of derivative. So we call this the first principle of the derivative. So now we are going to use this first principle of the derivative to find the derivative of a couple of functions. So this question has basically 4 parts. So the first part is basically, you have some function, let's call it, for example, f of x is equal to x cubed minus 27. So if f of x is equal to x cubed minus 27, I can write f prime of x. Which is equal to d by dx of f of x, which is the same thing as d f of x by d of x by dx. So any notation you could use, that is equal to the limit of the same thing over here, the limit of f of x plus h minus f of x over h as h tends to 0. So now in this function basically f of x plus h is basically equal to f of x plus h is equal to x plus h whole cube minus 27, and so what that means is that this is, you can write this as so a plus b whole cube is equal to a cube plus b cube plus 3ab plus, a cube plus b cube, a cube plus b cube is equal to a plus b whole cube. A plus b whole cube is equal to a cube plus b cube plus 3a squared b plus 3ab squared. So I can write this as x cubed plus h cubed plus 3 times x squared times h plus 3 times x times h squared minus 27. So then I can write the f prime of x. Is equal to basically the limit of f of x plus h, which is basically this function over here, x cubed plus h cubed plus 3x squared h plus 3xh squared plus 3x h squared minus 27 minus f of x. So minus f of x would be negative x cubed plus 27 over h as h tends to 0. As h tends to 0. Now here you can cancel out 27 and 27, x cubed and x cubed. And you have these three terms left here. So I can write this as the limit of h times h squared plus 3x squared plus 3x times h over h as h tends to 0. Now these two you can cancel out. Now this is then equal to the limit of h squared plus 3x squared plus 3xh as h tends to 0. And in the limit, when h tends to 0, this goes to 0, this goes to 0, and then you're left with 3x squared. 3x squared. So that means that when your f of x is equal to x cubed minus 27, then d by dx of f of x, which is equal to f prime of x, using the first principle of the derivative, or you could use really anything, but using the first principle is equal to basically 3 times x squared. And that makes sense because if you have, for example, if you have basically x cubed minus 27, you know that if you take d by dx of f of x, this is equal to d by dx of x cubed minus 27, which is equal to d by dx of x cubed minus d by dx of 27. Of course, this is based on the algebra of the derivative and everything else that we talked about later, after the first principle of the derivative. And so we said that basically the d by dx of x raised to the power n is equal to n times x raised to the power n minus 1, and d by dx of a is equal to 0. So now here I have, so based on this becomes 3 times x raised to the power 2 minus 0, which is equal to 3x squared. So that is basically that. Okay, so the next question that we have here is derivative of some other function, and it seems to be a little bit, I mean, I did do this twice, and let's see if we can do it this time, because I made mistakes. I did try to do this, but then I had a couple of problems. So let's say that your f of x is equal to x minus 1 times x minus 2. X minus 1 times x minus 2. And you want to find the derivative of this function. So basically the derivative of this function, before we do this, is going to be, I have calculated this, and it's equal to basically 2x minus 3. 2x minus 3. Now, since we want to use from basically the first principle, so then basically we said that d by dx of f of x, as x tends is equal to basically f prime of x, which is equal to the limit of f of x plus h minus f of x over h over h as h tends to 0. As h tends to 0. Well, let's see if we can do this. So basically I need the value of f of x plus h here. So to calculate the value of that function, excuse me. So the value of f of x plus h is equal to f of x plus h is equal to basically x plus h minus 1, x plus h minus 1 minus 1 times x plus h minus 2. So this is equal to x squared plus hx minus 2x plus hx plus h squared plus h squared minus 2h minus 2h minus x minus h plus 2, and that is equal to x squared plus h squared minus 2x minus x is minus 3x, hx plus hx is equal to plus 2 times hx plus 2 times hx, and negative 2h negative h is equal to negative 3 times h plus 2 plus 2. So you have x squared negative 3h plus 2. So you have x squared plus h squared minus 3x plus 2 times hx minus 3h plus 2. And basically to calculate f of x plus h minus f of x, that would be basically this whole expression over here minus f of x, which is equal to minus x minus 1 times x minus 2. So this is equal to basically x squared plus h squared minus 3x plus 2 times hx minus 3h plus 2. And over here what you have is negative of x squared minus 2x minus x plus 2, which is equal to negative of x squared minus 3x plus 2, which is equal to negative x squared plus 3x minus 2. So I can write here minus x squared plus 3x minus 2. And so these will be cancelled out, and these will be cancelled out, and these will be cancelled out. So then you will get basically h squared plus 2 times hx minus 3 times h. So that is the value of this expression over here. Now we said that basically we wanted to calculate this, the limit of, we said that f prime of x was equal to basically the limit of f of x plus h minus f of x over h as h tends to 0. So then you can write this as the limit of h squared plus 2 times hx minus 3 times h over h as h tends to 0. So then you can write this as the limit of h times h plus 2 times x minus 3 over h, and you can cancel these out as h tends to 0, which is equal to the limit of h plus 2x minus 3 as h tends to 0, which is equal to the limit of h as h tends to 0 plus the limit of 2x as h tends to 0 minus the limit of 3 as h tends to 0. So the limit of h when h tends to 0 is equal to 0. The limit of 2x as h tends to 0 is equal to 2x. And the limit of 3 as h tends to 0 is just basically a constant function, and the limit of this constant function the limit of this constant function is basically equal to the value of the constant function, which is equal to 3. So this is equal to 2x minus 3. 2x minus 3, and that is the value of the correct value of the derivative of the function, which I basically miscalculated. And the mistake that I was making was that I wrote this part, the limit of 3 as h tends to 0, I wrote this as 0, which is wrong. The limit of 3 as h tends to 0 is equal to 3, because you can think of this as a constant function. F of x is equal to 3, and that would be basically 1, 2, and 3 over here. So this is f of x is equal to 3. Now of course this h over here is basically the distance between 2 points on the graph of the function. For example, x is equal to a, for example, and some x is equal to a plus h. When h tends to 0, then basically these 2 points will basically a plus h tends to basically a, for example. The 2 points gets very close. And of course, you can see that wherever you go in this function, the limit of the function, or the value of the function, is going to be equal to 3, 3, 3, and so on and so forth, from negative infinity all the way up to positive infinity. So then you can say that, of course, the limit of 3 as h tends to 0 is equal to just simply 3. So that is that. Now the next question that we have over here is the limit, you want to find the derivative of 1 over x squared. You want to find, if suppose that your f of x is equal to 1 over x squared, and you want to find f prime of x. You want to find f prime of x. So in order to calculate that, again, using the first principle, you want to calculate d by dx of f of x. d by dx of f of x, which is equal to the limit of f of x plus h minus f of x as over h as h tends to 0, and and that is equal to in this case basically f of x plus h is equal to 1 over x plus h whole squared, which is equal to 1 over x squared plus 2 times hx plus h squared plus h squared. So that is the value of f of x plus h. So now to calculate this part, you can write the d by dx of f of x is equal to the limit of f of x plus h, which is basically this value over here, 1 over x squared plus 2hx plus h squared, minus f of x, which is minus 1 over x squared over h as h tends to 0. Okay, and so that is equal to the limit of basically x squared x squared plus 2 times hx plus h squared times x squared. I need to write this a little bit better, basically down here. So I can write this as the limit of the numerator becomes x squared plus 2hx plus h squared times basically x squared. So this is your LCM. So you will get x squared over here minus basically this whole thing over here, which is x squared minus 2 times hx minus h squared over h. Now these two will cancel out, and then you can, and this is as h tends to 0. You can basically, this is divided by this, so if you have, for example, a divided by b divided by c, that's equal to a divided by b times 1 divided by c, which is equal to a times a over bc, a over bc. So I can write this as the limit of h tends to 0 of basically a divided by bc, so negative 2hx minus h squared over a over bc, so h times x squared times x squared plus 2hx plus h squared. And so I can write this as the limit of h tends to 0 of basically h times negative 2x minus h over h times x squared plus 2hx plus h squared. And then h and h you can cancel out. So basically what happens is that in the limit, so you have basically the limit of these two the limit of these two expressions. So I can write this as the limit of h tends to 0 of negative 2x minus h over the limit of h tends to 0 of x squared times x squared times x squared plus 2 times hx plus h squared, and so this is basically again equal to the limit of negative 2x as h tends to 0 minus the limit of h as h tends to 0 over the limit of basically this whole thing, so the limit of x squared as h tends to 0 times the limit of x squared plus 2hx plus h squared as h tends to 0. This is the limit of this, and of course again over here the limit of negative 2x as h tends to 0 is equal to negative 2x. This is equal to 0. The limit of x squared as h tends to 0 is equal to x squared, and this is basically x squared, and these two will be zeros, basically 0 plus 0. So you have basically negative 2x over x squared times x squared. So you can write this as x, and x you can cancel out. You have x over here. So you have negative 2 over x cubed. So that means that when f of x is equal to 1 over x squared, then f prime of x is equal to negative 2 over x cubed. That is basically the answer here. Take a look at the answer, negative 2 over x cubed. Okay, so that is that. Now suppose you have the limit, the derivative of another function.